Now the next problem, assignment problem. Connected to X voltage means voltage is given. How much is the voltage? 347.5 volt. Frequency is also given 50 hertz. AC source, a balanced three phase load, draws a line current. Line current means VIL. Automatically I told you the voltage is VL only. The Y ampere means 34 ampere. The input power is recorded by using two wattmeter reading, where the reading are 2:1, means W1 is to W2 ratio is 1 is to 2:1, right? This one is the given. Now see what they have asked. The active power of the load is. Active power we need to calculate. First you tell me. The power formula is root 3 VL IL cos phi, but we don't have, we have root 3, we have VL, we have IL, but we don't have cos phi. So cos phi formula is cos of tan inverse root 3 W1 minus W2 divided by W1 plus W2, right? So we have W1 and W2 ratio, right? So can we substitute the ratio over here and then we'll get cos phi? We can substitute the cos phi over here, then we'll get the active power. So can we write it like this from the ratio? If we substitute it, W1 is how much? 2W2 minus W2, right? Divided by W1 is how much? 2W2 plus W2. So that would be how much? W2 divided by 3W2. So this would be cancelled, right? So the final answer would be cos of tan inverse of root 3 into 1 by 3. Now you can solve this by using calculator, then you will get cos phi. You can substitute cos phi, then you will get active power. Now next one is they have given X and Y, the reactive power of the load is. If you will be able to get the active power, then you will be able to get the reactive power as well. Root 3 VL IL sin phi, right? So from by the same method calculate cos phi, from cos phi calculate sin phi, and then you will get the reactive. Next, the problem third, a balanced delta connected load is supplied by a three phase, means there is delta connection and the voltage they have mentioned as 408 volt, right? And F frequency, F hertz. F they didn't mention. Let us consider 50. Okay, drawing a line current of, line current means IL and this one is the VL. As I told you, if they didn't mention, we have to consider the line voltage only. IL is how much? They have mentioned 17.50 ampere at the power factor 0.8 lagging, right? So what you need to calculate the resistance of the load branches. Basically, if they ask you the resistance, then you need to calculate impedance, that is ZPH, right? In delta connection, voltage is same and current is different. So we'll have one formula, that is VPH is equal to IPH multiplied by ZPH. VPH is same, that is 408 volt. IPH is different. What is the relationship of current in delta? That is IL is equal to root 3 of IPH. So IPH is how much? IL by root 3. We can get ZPH, right? Now they have said cos phi is 0.8. Cos phi is 0.8. So we can get the phi angle from here, that is cos inverse of 0.8. So if we'll put the value 408, IL is 17.50 divided by root 3 multiplied by ZPH. Can we get the value and the magnitude for the ZPH from here? And angle is phi, we can get the angle from here. Yes or no? See, phi angle we'll get it from here, cos inverse 0.8, 36.8, and after solving it we'll get 40.38. They are asking r, so convert it into the rectangular form. Rectangular form is r plus jxl. So after comparing the equation you will get the resistance, right? And in the next part they are asking reactance. Reactance means xl only. If they didn't change the value, then that would be much easy. Every time they are changing the value and every time you need to repeat it. R is 32.305, and similarly you can get XL as well, right? Now see from this question only, question number 9, like from this problem 3 only it is associated. If X is this one, Y is this one, means voltage is 352.5 volt and current is 30 ampere. The power consumed per phase, they mention a per phase, so we'll use the formula VL IL cos phi. Okay, so VL is given 352.5, IL, this one is IL is given 30 ampere, and cos phi you already calculated by using R by Z, or phi you already know, that is 36.86. No, actually the value will change now. The value will change. No, they have given you directly the power factor, that is 0.8 lagging. So you do, in this you don't need to change it further, 0.8. Okay. Now similarly they again change the value voltage and current. Now this time they are asking the reactive power, so that would be VL IL sin phi. VL is how much? 434. Current is how much? They have given the line current, that is 23.5, and the sin phi. If cos phi is 0.8, then you can calculate sin phi, that would be 0.6. Okay, see in this they mention reactive power of the complete system, so this would be root 3, mention root 3, but in the above case they said per phase, that's why I didn't mention root 3. Okay, fine. Now the next part, again they change 1449.5, current is given 39.25, PL and IL. Frequency also they have mentioned 72 hertz. Inductance, so we need to calculate impedance, right? Now the formula VPH is equal to IPH into ZPH. Remember I told you we need to never use this formula, VL is equal to IL into ZL, right? So VPH is equal to IPH into ZPH. V in delta, VL is VPH, so 449.5. IPH is how much? IPH is IL by ZPH. Yeah, this is delta connection only. In the delta connection, voltage is same, right? Now can you get ZPH? Again ZPH magnitude you will get it, and angle is how much? Cos inverse of 0. Then again convert it into the rectangular form, then you will get XL, and after getting XL, XL is equal to 2 pi FL, will get L, right? Because Z is in the form of R plus J. Understood? Alright. The load pattern shown supplied by a 3-phase dash volt RYB, RY as a reference, and this one they have given. So ZR is X angle 120 degree, means this one impedance. ZY have taken as Y angle minus 50 degree, this one impedance, and ZB they didn't give it, Next one, they have mentioned the voltage. Okay, some amount of voltage, line voltage they have mentioned, and this is for star connection. So in case of star connection, current is same but voltage is different, right? So if value of this one ZR, ZY and voltage is given, we need to calculate the magnitude of IR, and if the angle is minus 180 degree angle, okay, current angle then minus 180 degree. So we know the formula VPH is equal to IPH multiplied by ZPH, right? The star connection current is same, so IPH we need to calculate. Z, how much they are particularly asking for IR, so we'll take ZR. ZR value is given, that is X angle 120 degree. VPH is L by root. Voltage they have given it to you, that is 328 point something divided by root 3. Okay, so can you get IPH from here? Tell me. See, in the next part they are asking voltage they have given, X is uh, current they have given, angle they have given, the magnitude of current IY. In the last case they are asking IR, and in this case they are asking IY. So can we do it by the same pattern?